Hi, my name is John Joseph, and this is the 8th video in my tutorial series on my procedural text generation tool, ProcGenie. In this video, we'll talk about using tags as constraints on generation. As you'll recall in the last video, we talked about setting and removing tags on reference objects using the syntax. For setting tags, we'd use the syntax happy old. So you put a plus sign, parentheses, and then the name of the tags. For removing tags, a minus sign, parentheses, and the name of the tag you want to remove from a reference object. So in this video, we'll talk about how we'd use those tags that we set on our reference objects as constraints on generation. Ultimately, the purpose of setting and removing tags is to define constraints. To check whether tags exist on a reference object or a set of reference objects, you use the syntax question mark, parentheses, tag name. So let's say that we set a reference object to John, and we set a tag on it, old. And we want to have text that changes based on what tags are set. So we could have John is young. And then if you want to check the constraint, remember, use the question mark, parentheses, tag name. So is John young? Well, let's use question mark, parentheses, young, to check whether John's young. And then we'll define another component in that cell, John is old. And we'll use that same syntax, question mark, parentheses, old. Now if we press run, John is old. So what happened? The walker started at a start symbol. A production rule said that it could go right, east, or x plus 1. A reference object was set to the object John, so John didn't exist before, so it creates a new reference object named John in the list of objects in the generator. A production rule says that it can go east or right, x plus 1. A tag is set to old. A production rule says that, again, the walker could go east. And then you get to this cell with two different components. There's a John is young component, and that has a constraint defined with this question mark, parentheses, young. So if the tag young exists on the currently set reference object, then this text is available. If the tag, and then there's another component, if the tag old exists on the currently set reference object, then this text is available. Well, we just saw that we set the tag on the currently set reference object of John to old. So every time you run, you'll get John is old. But let's say instead of young, we said lazy. John is lazy. And we have a constraint that checks to see whether John is lazy. And then instead of just old being set as a tag, let's say we also set lazy as a tag. So that in this case, you have a start symbol, you move, you set a reference object to John, you move and you set tags to old and lazy. So the tags old and lazy are set on the reference object John. The production rule east says that you can keep going, right? And then you have two components. John is lazy with a constraint set that the tag lazy has to exist on the reference object for this text to be available. And John is old with a constraint saying that the tag old has to exist on the reference object for this text to be available. So the walker would set the tags, and then it would move here, and it would have to decide between the two components. Does it choose John is lazy, or does it choose John is old? Well, what happens? If we click run, we see John is lazy. Now this might be something that you don't expect, but let's try clicking run again. John is lazy. Every time we click it, we're getting John is lazy. Why is that? Well, both components are available to the walker because old was set and lazy was set. But as you'll recall from an earlier video, if you don't set a probability factor on a component, regardless of whether a constraint's called or not, if you don't set a probability factor on the component, then it's basically like an if-else block. So if John is lazy, then set to John is lazy. If John is not lazy, but John is old, then set to John is old. To avoid that result, we'd add a probability factor. So here we'll give a probability factor to each of the components of 1. That way, when the walker gets to this cell, it's going to look at the constraints that exist on the components. And it'll say, okay, lazy's met, so I could go to John is lazy. Oh, old is also met. I could go to John is old. Now there's probability factors involved. Which one should I choose? Well, it's going to choose one of the two based on a pseudo-random selection. So if we click Run Now, John is lazy, John is old. John is lazy, John is lazy, John is lazy, John is old. So you see, again, you set a reference object, you set tags, and then you can check those tags. But when you do, if you want all of the different options to be available, then you need probability factors. And once more, to check whether a tag exists on a reference object, use the question mark, parentheses, tag name. But let's introduce what we would do if we want to check whether a tag does not exist on a reference object or a set of reference objects. In that case, instead of the question mark, we'd use an exclamation point. So, John is lazy. Or let's change this to, instead of lazy, let's change it to industrious. John is industrious. We would only get this text if lazy is not set on the reference object John. So let's see what happens. John is old, John is old, John is old, John is old. So as you'd expect, lazy has been set. When the walker gets here, it sees that this text, John is industrious, is not available because you have a constraint checking whether the tag lazy does not exist on the reference object John. Again, the exclamation point parentheses checks whether a tag does not exist on the reference object. Now, as with reference objects, you can check, and with adding tags or removing tags, you can check whether multiple tags exist at the same time. So in this case, we could add another component, John is old and lazy, and we'd check whether old and lazy were set on the reference object. If we click Run, John is old and lazy. Sometimes you'll get John is old, sometimes you'll get John is old and lazy. Again, you're still not getting industrious because lazy does exist on the reference object. Similarly, you could get John is not old or lazy, and we can use that same syntax where multiple tags are checked within the parentheses. So we'd have old, lazy. Here we'd check whether John is not old or lazy. Let's run that. John is old and lazy. Check. John is old and lazy. But what if we go back here to get that last result? Instead we say industrious. Add the tag industrious. So now you have a probability factor of 1 on each of these components. We've defined 2 components in the cell. Either of them could be selected, and then you'd move on and you'd try to see what text you get. John is old and lazy, John is old, John is industrious. So, at least on one occasion during that generation run, we got John is industrious. What happened? Well, you started with a start symbol, you set a reference object to John, you moved to this cell. The cell had 2 components. One set 2 tags, old and lazy, on the reference object John. The other component set 1 tag, industrious, on the reference object John. They both had a probability factor of 1, so the walker chose randomly between them. And then, using the directional or production rule east, the walker moved to the right and decided between 4 different components. John is industrious, John is old and lazy, John is not old or lazy. And in each case, the walker checked the constraints to see whether those constraints were available, and if those constraints were met, then the walker would add that to the list of possible components. Then the walker would use the probability factors to choose pseudo-randomly between the 4 components. And that's it. That's using tags as constraints on generation. So, 2 things to be aware of, though. Tags are checked when you're looking to see whether a component is available. Tags are also checked We've seen that here. Tags are being checked to see whether a component is available in a cell. Tags are also checked if we're checking to see whether a cell is available in response to a production rule. Let's see how that works. Add a start symbol, and let's say that we have a tag that we set to happy. And we set two directional or production rules. And in one cell, we'll say John is happy. And in the other cell, we'll say John is unhappy. And we'll check whether the tag unhappy has been set on the reference object John. So you set the tag happy, and here we actually don't have it set as John, so we should fix that. We'll set the reference object to John. Okay. So you have John set as the reference object, happy set as a tag, and production rules stating that the walker can then move northeast or east. If we click run though, John is happy. It did not run, John is unhappy. Why? Because as I was just saying, the second point where tags are checked, we saw how they're checked as whether components on a cell can be selected. But the second point where they're checked is as a constraint before a cell is chosen as the next step for the walker. So here, the fact that unhappy is not met means that the production rule right here, E, basically just can't run. If there were other text on here, doesn't matter whether John is happy. And we run that, we might get some of the old results, but doesn't matter whether John is happy. Okay, so that cell is now available because there's a component on that cell that meets the constraints. There's no constraints here, so the walker is able to move there. Now, one thing you might have seen there, I ran multiple runs here, is that there were two start symbols. And so when I ran the multiple runs, you were seeing some of these results and some of these results. And that's just one of the benefits of having multiple start symbols. You can have generators running across your graph, and you can have multiple start points on your graph. Again, we've looked at tags and seen how tags can be added to reference objects. We've seen how tags can be removed from reference objects. And now we've seen how tags can be used as constraints on reference objects. That's either by checking whether the tag exists or checking whether the tag does not exist on a reference object.